Okay, hello everybody. Welcome to Maths today. I'm sorry I can't be there in the flesh. We'll just quickly go over what we did on Monday's lesson, then we'll go through the work for today. It's not too intensive today, and it builds on quite a lot from Monday's lesson. So let's have a look. So on Monday, we looked at reducing balance loans. So this is the formula we use. And remember, a reducing balance loan is where you are paying off the loan as it is earning interest. So your first payment, in this example we did here, was $250. Sorry, your first interest, your interest accrued was $250, and you paid off $1,000. So you had to pay off that $250 of interest first, and then you paid off an additional $750, which left you with $4,250 of your loan remaining. The next time you had an interest payment, instead of being off the initial principal of $5,000, it was off $4,250. And after you calculated your interest, $212.50, paid off $1,000 for the compounding period, you're down to $3,462. So the reason we call it reducing interest loans is if you look at the interest, $250 down to $212, down to $173, down to $131. So that's where we get the reducing interest loans from. And we looked at our recursive definition of the rule. So remember, instead of AT plus 1, think of it as the next amount. So the next amount is equal to the interest rate times the current amount. So AT is the current amount minus whatever your repayment is. And we did a couple of practice ones, and this is the one I messed up as well, remember. So remember, when you're doing the interest payment, you have to do the percentage interest divided by the number of compounding periods per year times 100, and then you plus 1 to it at the end. So if you had 14% interest compounding yearly, it's 14 divided by 1 times 100 plus 1 to get 1.14. If you had 11.2% interest compounding quarterly, it's 11.2 divided by 4 times 100 plus 1, which gives you 1.003, which you then use as your R value in your recursive rule, like up there. Okay, so that's what we looked at on Monday, is just how to calculate the amount of principal remaining after a certain amount of compound periods, which is all that recursive formula finds us. So what I want to do quickly before we go on to today's work is just do a quick example. So bear with me while I flip my screen around. So I'm going to do 3 payments. Let's say your principal, we'll use the correct term, your A0 term. This is how much your loan is originally for. Let's say $5,000. Your interest rate is 8.3% per annum, compounding, let's say monthly. And this is for, I don't know, let's do three compound periods. So I should write this as a question. How much principal after 3 compounding periods, 3 months? I'll just write that, 3 months. So the first thing I would do is generate my recurrence relationship. So the next amount of money that is going to be remaining in that account is equal to my interest rate times the current amount of money in that account minus my repayments. Which reminds me, I didn't say how much I'm paying back each compounding period. Let's say paying back, so repayments, the amount I'm paying back are 800 per month. 800 a month. So the way we calculate this is we'd first find our two R values. So little r is our interest rate. Now I said my interest rate was 8.3. So 8.3 divided by the number of compounding periods per year, which is, I said, monthly. So that's 12 times 100. And I just plus 1 to it. So putting that into my calculator, I get 8.3 divided by 12 times 100. I get 0. Once you plus 1, 1.0 That's not right. Sorry, I appear to have made a mistake in my calculator. Let me just try this again. 8.3 divided by 12 times 100. There we go. I hadn't put my 100 in brackets, and that was giving me 69% as an answer. 69.16, which, looking at that, just isn't right. So I was able to tell that I made a mistake there. So the actual answer, should be 1.00691. So we'll round that off to 69. Okay, and then obviously big R is just my repayment amount, which is 800. So to find my next amount, I take my interest rate times my first amount minus my repayments. So the only value I know at the moment is the initial amount, A0. So I'm going to say that A1 is equal to my interest rate, 1.0069, times my principal for my A0 term, 5,000 minus 800, which gives me 1.0069 times 5,000 minus 800, $4,234.50. What I might get you guys to do as an exercise is to find A2 and A3. So if you want to pause the video here and have a go at finding them, that would be fantastic. Welcome back. I assume you've paused the video there, and you have your answers for A2 and A3. If you are still unsure about this, please do finish off the independent practice from the other day. So let's get on to today's actual work. So we're looking at repayment schedules and solving problems, once again, with reducing balance loans. So a repayment schedule is a visual way of looking at how a loan is progressing. So literally, all these are is a table like this. So this is our repayment schedule. You can see after we've paid 0 repayments back, we've repaid nothing. We've paid no interest. My principal has not reduced, and the balance of my loan is $1,000. After 1 repayment, I've paid back $250. I've earned $12.50 interest after my first compounding period. And because I've paid back $250, but $12.50 of that went to interest, in total, I've paid off $237.50 off my original balance, the principal, which means that my current balance is $762.50. So this is how much interest we've been charged that year. You can see the amount that compounding period. You can see that it goes down each time, and the amount of principal we paid off, because the interest is going down, the amount of principal, more of that money that we're paying is going towards the principal rather than paying off the interest. So we're getting closer and closer to 100% of our money being paying off just the principal. And you can probably see here, it would only take 2 more payments to pay off the entire balance of that loan. Okay, so let's have a look at a couple of questions. What is the principal of this loan? Well, the principal is just the balance at the start, so that would be $1,000. What are the repayments? Well, that's just how much we're repaying back each year, $250. And how many more payments do you think would be required? Well, I've jumped ahead of myself and said, I reckon that would be 2. Because the next payment, looking at this, you're going to get like $3 or $4 worth of interest. And once you pay off $250 odd, there's still going to be part of a payment left over. So in that final payment, you probably won't have to pay a full $250. You might only have to pay, 30 or 40 bucks. Okay, so let's have a look at another repayment schedule. So this is going to ask us, let's jump ahead here. What is the principal value of the loan? Well, looking at this table, all I've got to do is look at that first row and see the original balance, $8,500. $8,500. Okay. So B, calculate the value of A, the principal reduction from repayment number 3. So we're trying to find this A value here. Then we're going to find B. So we'll talk about those two first. So let's have a look. In this third repayment, we're paying off $600, but this interest period, we have earned $47.39 of interest. So what we have to do is just figure out how much the balance has gone down. And basically the way this works is $47.39 of my payment has been consumed by interest. So instead of going off to pay the money I actually owe, that's just paying for the interest on the account. So A is just going to be the difference between the payment and the interest. So A equals $600 minus $47.39, which I'll put that into my calculator and see what I get. 600 minus 47.39, $552, 52 and 61 cents. So the value of A, the principal reduction, is 552.61. Okay, calculate the value of B, the interest paid with repayment number 5. Okay, so we're sort of going to do the opposite thing here, where we know that we paid $600 into the account, and that reduced the principal by $559.70. So the difference between these two numbers is going to be how much interest I actually got charged this year. And just for my own self-checking, I can see that in payment 6, the interest was $36. In payment 4, it was $43. So I would expect my answer to be somewhere between 36 and 43, and if it's not, I will have made a mistake somewhere, which, you guys were there for the last lesson, is probably very possible. So the way we're going to find the difference here, just 600 minus 559.70. 600 minus 559.7, and that will give us a number, and that number is $40.3, because it's a dollar amount. We add that second decimal place as a 0. So $40.30, $40.30. And does that fit with my guess from before? It's going to be between 36 and 43. Yeah, it is. So that checks out. So that's good. Okay, question C now. Calculate the total interest paid after 6 repayments. Now, there's a few ways you could do this. We just figured out what B is, so we know the interest paid each compounding period. So you could just add up those 6 numbers, and that would answer D. But that's a bit of an inelegant solution, so I want to do it a bit more of a sneaky way. What I want to do is, I know how much I have paid. Over the 6 compounding periods. I paid 6 lots of 600. So 6 times 600, and that's going to equal $3,600. I also know how much the balance has gone down. So this is my payment total. The balance reduction, how much money of the principal we've actually paid off our account, is just going to be how much we started with minus how much is left. That's going to be 8,500 minus 573.58, which is 8,500 minus 5,173.58, which is $3,000. $326.40. Okay, so I hope you can see where I'm going now. I've put, theoretically at least, $3,600 into this account. So I should really have a dollar sign next to that because it's a dollar amount. However, my balance has gone down by about $330 instead. So what that means is the difference between this number, 3,600, and this number, 3,326.4, is how much of that money has gone towards interest. So all we need to do is then minus those two away. So interest paid equals 3,600 minus 3,326.4. Like I said, you could just add up those values, but I find putting 6 numbers into a calculator boring. It might actually have been faster, but I do want to show you more than one way to do these problems. 3,326.4, and that gives us $273.60. So you can choose either way to answer that problem. I would suggest that if there's only a couple of numbers, just adding up the interest would probably be quicker. If there is like 20 payments, I would definitely do it this way because I've done it in 3 calculations, and 3 quite simple calculations I've got to an answer. Whereas you don't want to be sitting there putting 25-digit numbers into your calculator because there's a good chance you'll make a mistake. Okay, with that being said, that's all we're looking at today is just these payment schedules, these table of values showing us how much money is left in the account at every stage. So just to recap, the things you'll need to know: repayment schedule looks like this. This is always your balance, these ones. And then you just have your different columns giving you the important information. And the other thing that we talked about today was just your recursive definition of a reducing balance loan. AN plus 1 equals R times AN minus R. And that's what we were doing on Monday. So with that being said, can I get you whoops, my computer's freaking out on me. So can I get you guys to have a practice at these 3 questions, which should take you about 10 to 15 minutes. So if we put 10 to 15 minutes on the timer and pause the video, and we'll come back to that, and I'll finish off the next bit. So I'll leave a moment of silence, and we're back. So we're just going to look at these reducing balance loans and have a bit of a practice at solving like sort of problem solving scenarios. So basically we have a formula which is really helpful. So these are our variables. P is principal, N is number of compounding periods, A is the balance after N repayments. So in our recursive definition we would have been saying like AN, but we're just going to call it A here because we're not going to look at multiple different payments. Okay, I is the decimal interest rate per compounding period, R is the repayment made after each compounding period, and the balance of the reducing loan after N compounding periods is this rule. It's a long one, so we're going to have to get our practice in on it. So A is equal to P, 1 plus I to the power of N. This is just your compound interest formula. Just that is how you calculate compound interest. Then you're minusing R times this fraction, where you have 1 plus I to the power of N minus 1 in brackets, divided by I, remembering I is your interest rate. So we're going to have a go at this one. So remember, what this shows is how much money is in the account after a certain amount of repayments and compounding periods. So NOMSA has borrowed $8,000 at an interest rate of 11.28% per annum, compounding monthly. If she makes monthly repayments of $500, what will be the balance of the loan after 1 year? Round your answer to the nearest cent. Okay, so that's a pretty dense information question. So my first step is just going to be to list out all my variables. So I'm just going to read off from my formula all of the variables. We have A, P, I, N, R. We have I again, N again, and then I again. So we have 5 variables we're looking for. So I'm going to be reading this question again with an I for where my final amount, my principal, my interest rate, the number of compounding periods, and my repayments are. So Nomsa has borrowed $8,000. So that's not the final amount, that's how much the account is at the start. So I can say principal is 8,000 at an interest rate of 11.28% per annum, compounding monthly. Remember, so the interest rate is 11.28% per annum, but remember, we need to figure it out per compounding period. We can't just throw that 11.28 straight into our formula. So that's where we go 11.28 divided by compounding monthly is 12. Sorry, that does not look like a 12. I might zoom in on this so it's a bit clearer. Divided by 12 times 100 plus, I just need to check on this rule. We don't need to plus 1. The reason why we don't plus 1 is because it already has the plus 1 in the formula. So I know that's going to throw some of you to start with. So we just need to remember, when we're using this formula, we do not plus 1 to the interest rate because it's built into the formula. Okay? N. Remember, N is the number of compounding periods total. So a lot of people would see this and be like, oh, it compounds monthly, so therefore the answer is going to be 12. In this case, it will be because we only want it after 1 year. But if this question had said 2 years, N would be 24, not 12. If it was 10 years, it would be 120. So that's a really common trap that people put the wrong N value in. The last thing we need is monthly repayments of $500. Okay, so what will be the balance of the loan after 1 year? Let's just shove everything into our equation. A is a question mark, so we're just going to leave that as is. I'm going to write out the full formula to start with and then just substitute into it. A equals P, 1 plus I to the power of N minus R, double bracket, 1 plus I to the power of N minus 1, close bracket, divided by I. And just, if you're not sure, just remember that between that R and that fraction there is a multiply sign. Okay, what we've got to do now is just sub in our values and then put it in the calculator and solve. Instead of P, 8,000. Instead of I didn't actually calculate that, did I? Let me do that now. I is 11.28 divided by 12 times 100, 0.0094. Okay, 0.0094 to the power of 12, because n is 12. Why did I write 120? That was dumb. So n is 12, r is 500 times 1 plus 0.0094 to the power of 12 minus 1 divided by 0.0094. Now you're going to have to bear with me for a moment. I'll put this into the calculator and see what we get. 8,000 bracket 1 plus 0.0094 close bracket to the power of 12 minus 500 double bracket 1 plus 0.0094 close bracket to the power of 12 minus 1. In your calculator, after you do to the power, depending on what calculator you have, you may need to close a bracket or press the right hand arrow just so it doesn't keep writing the equation in that power section. Just be aware of that as you're doing it. My calculator does it automatically, but just check yours as you go. And then we close that bracket after that minus 1 and then divide by 0.0094. And that gives us $2,630 and 0.419. It says to round to the nearest cent, so 0.42. So after a year, she's actually paid off most of that loan. She only has about $2,600 remaining. So that's probably only about another 6 payments that she will make, and then she'll be all paid off. Okay, I'm cautious of time. So what I might do is split up the class, similar to how we did this on Monday. So can I have the front right group? Can you do A? So that'll be probably Brody, Lily, Carly. Can I then have the back right group? Can you, the back right and the middle right, can I get you to do B? Then can I have the middle group? So Sarah, Maddie, Haley, and that. Can you do C? Can I then have the Caseys do D? And can I have the boys at the front left and middle left? Can you do E for me, please? So just use that same formula. A equals P, 1 plus I to the power of N minus R, 1 plus I to the power of N. What do we do then? Minus 1. Minus 1. Whoops, sorry, that bracket should be up here. Divided by I. So just use this formula for your particular question. So just for the number of compounding periods. So for this one, you'd find it N would be 6. For this one, C, it's going quarterly. So 4 compounds per year. It's doing it for 5 years. So that would be N is 20. I just want you to find your ones. Okay. Once you've done that, can I get you guys to have a go at independent practice, page 341, exercise 8C, question 3 to 6. So just put that back up there for you to have a look at. You might want to pause the video there. I'll just rewrite the things up there. So page 341, Q3 to 6. So once you've done how to go at that question, and you guys in your groups agree that you've got it correct, can you then please have a go at question 3 to 6? And on that note, I'll end that video here today. And if you do have any problems, please feel free to leave a comment on the OneNote or let me know what you're not sure about. But aside from that, guys, I hope you have a fantastic rest of your day and enjoy your weekend. Bye.